Thanks everyone for joining. My name is Christina. As we mentioned, I'm on the product team here at Dataiku, and I'm so glad to be here with all of you today. For any of you who aren't already familiar with Dataiku, we are a software platform that really the goal is to enable teams to centralize and collaborate on their data and analytics projects across the entire end-to-end lifecycle. And so today we're going to focus on the back half of the life cycle, which is, what happens after the initial design phase of a data project is complete and you're ready to operationalize a machine learning pipeline. No surprise, given the conference focus. So we'll touch on some key concepts and considerations, talk about the different roles and responsibilities that are involved in MLOps, and cover some of the deployment, monitoring, and lifecycle management strategies that we think about here at Dataiku. And in the back half of the presentation, I will be using our platform just to show you examples of how we've implemented some of these concepts around drift and model management and things like that. But it's really more just to give you an idea of maybe one way to approach the general problem that lots of organizations have. So I thought I'd start by level setting, since MLOps is such a broad and conceptual topic. There's a lot of buzz. But I'm going to draw a little box around what I mean when I say MLOps today, and that is the processes and tools that allow you to safely and efficiently scale your machine learning in production environments. And so, I think of MLOps as this dance between primarily two functions: data science, or maybe you call it decision science, and IT operations. And they have a shared goal in this case of putting high quality model systems into production and then keeping them running in peak form amidst a changing environment. And doing all this in as efficient and controlled a manner as possible. So one thing to remember is that good means different things to different people. And each function has different concerns when it comes to what they consider a well-performing model system. So for example, the data scientist who maybe was instrumental in developing the features or the algorithm and kind of putting it all together, once it goes into production, they care about, well, is it still performing well? Is it accurate? Is it degrading? And as data and environment changes, does the model still fit the external conditions? The ops folks, maybe that's kind of like a modified DevOps who handles MLOps now, or some other group. They care about those things, of course. But moreover, on a day-to-day basis, they're monitoring things like, are we meeting our SLAs? Do we have outages due to pipeline breakage? Are we using the right amount of compute? Do we need to make things more elastic and scale our hardware strategy and all those types of issues? And then don't forget, there's the actual consumer, which in many cases is, first of all, an internal business stakeholder who cares about, well, is this working? Is the effort that we've taken and maybe funded to develop and maintain this model, is it delivering the business benefits that we want? And lastly, risk. And these folks are continually seeking to protect the business from operational risk, reputational, regulatory risks. And so they're asking questions about, can we reproduce it? Can we prove to regulators the methodology and why we made the decisions we did, and that it's fair and unbiased and things like that? And so the questions they ask are often the core drivers of governance, which is one of the things we'll talk about at the very end. So stepping back into machine learning, you'll quite often see this sort of simplified life cycle. And what happens a lot of the time is when organizations are just starting their AI or ML journeys, they hire some really smart people with this very kind of unicorny skill set of computer science and statistics and coding and whatnot. And the data scientist does a lot of the heavy lifting across this entire life cycle. And then once they've built a POC or a prototype, they kind of throw it over the wall to IT and say, well, we built you this, go productionalize it. And IT, if they get to it within 5 or 6 months, they oftentimes have to reverse engineer a lot of that project logic and then sometimes recode it in a different language, or to harden it and make it compatible with production infrastructure. They're not in a sandbox anymore. Now they're connecting to the real databases, and directly maybe with customers on the other side. So for the first few projects that actually make it into flight, the data scientist is still really the on-call expert that they call when things break. And that works okay for maybe the first 1, 2, 3 projects. But when you go from 3 to 30 or 30 to 300, the level of dependence upon the data science function becomes quite unsustainable. So you need something more systematic. And of course, we know in reality that simple model is not the full picture. The tail ends of the life cycle about data collection, storage, management, governance, and then on the backside with keeping the lights on, those are really full-time functions and teams in larger organizations. So as a company grows in this maturity curve, we start to see full-time data engineers handling the front part, and ETL and low-level source data. Data analysts maybe do initial data blending and wrangling, and then they hand it over to data scientists who spend time on the piece of the puzzle they really love best, maybe developing a model to represent that system. And then IT ops incorporates that final developed solution into an established MLOps framework to deploy and then maintain it over time. So as you scale up, more and more separation of duties becomes possible. And my goal today is to convince you that in an ideal state, with the right platform and tooling and processes in place, the separation of duties can occur without sacrificing collaboration and transparency. And that's because that handoff, that last leg handoff between data science and IT or ops is one that's it's important to try to get as much autonomy in the hands of ops as possible. And it's not to say that the other folks, data engineers and scientists and analysts, never come back into the loop if something changes or goes wrong, but the more self-sufficient the ops team is to manage and retrain and troubleshoot and things like that in production, the better. So to kind of close off this thought, I'll give you 3 reasons that I thought were quite kind of convincing that our GM of business solutions said once, and her name is Sophie DNA. And she said, the reason why you want to have this handoff is first, very basic. It's just bandwidth. So data scientist talent is really scarce. And so you want to preserve their capacity for developing and evaluating new solutions. And the overhead of maintaining dozens of models in production really prevents them from innovating on new stuff. The second reason is know-how. Good designers aren't always the best implementers, and most data scientists are not trained developers. So you wouldn't necessarily ask a car engineer to himself or herself run the manufacturing chain, or maybe an energy industry analogy. You wouldn't ask the person who designed a new energy source to run its operationalization and distribution in an energy network. And so it's really about skill sets. The third piece is risk management. Machine learning drives very specific risks for an organization. And so as AI becomes more embedded and its criticality increases, so too does the need to have rigorous segregation of duties and process oversight for governance purposes. So you know who's supposed to do what and who did what at any given time. So I know we're focusing on MLOps, but I just want to take a moment to say I would be remiss if I didn't mention that data ops, data pipeline ops, is absolutely critical. An ML algorithm by itself is useless. It's I think of it like a brain without the data that it's its lifeblood and the skeleton and muscles that execute the brain's decisions. Like you need that underlying data framework to not be broken in order for the entire system to function. So I really combine data pipeline operations somewhat with ML model ops because they're not so different in many cases. So the first thing we're going to talk about is sort of getting ready for production, the types of baselines that you want to take before you go ahead and push it into a tested or prod environment. We'll talk about how to monitor something once it's live, different ways to calculate whether there's drift. We'll talk about resource monitoring and understanding health. And then lastly, we'll cover governance. So the first thing we'll cover is just how do you deploy? Now, this is very dependent upon your set of tooling and the processes you have in place. Maybe for some of you, you really work heavily in notebooks, and deployment means handing over a bunch of chained together notebooks or scripts to that IT group. And then it's sort of like magic. Maybe they recode in Java and it gets embedded into a batch job somewhere, or maybe coded into an API that's used by an application. So what I want to show you is at least the way that we kind of approach deployment with wrappering a pipeline, maybe scheduling it, and then transporting that into, like, kind of lifting and shifting that into a test environment. And then again, lifting and shifting it into a production environment with versioning and state captured, whether that's batch or API. So I'm gonna hop over here and show you how we tackle some of these topics. Now, this is Dataiku's interface. I'm not going to take a lot of time at all to really explain to you what you're looking at. We definitely have lots of information at the booth if you want to go learn more about the platform. But for now, let's just assume we have a use case the business is given to us of trying to predict whether or not a healthcare provider is going to prescribe your treatment in the next 30 days. And you want to know this because maybe you want to tailor the marketing offers you give to them if you're, let's say, a pharma rep. So we've built this pipeline. You take input data, you transform it, maybe you build a machine learning model, and we want to operationalize this in a few ways. The first is to, on an ongoing basis, take new data, the next month's data coming in. We want to score it based on our model that we've developed and push it to Power BI. Okay, so that's this little branch. Simultaneously, as this is running in a scheduled way, I want to check whether or not my model's drifting. Maybe we've created an API so that the rep can hit this on their iPad, and while they're sitting in the lobby or the parking lot of a healthcare provider, they say, what's the likelihood they're going to actually purchase from me? They have an API. You want to check the drift on that also. And then we'll talk about A/B testing at the end. So the first thing is, how can I schedule this, right? I don't want to have to come in here and hit run on a user interface in order to have this run every 2 days or whatever. So you might want to use a scheduler, and there's lots of open source and proprietary schedulers. I'll show you what ours looks like. You can see here we have different types of automation scripts set up. Let's say monthly scoring. What you'll want to do is define how often you want it to run, if it's a time-based trigger, or what the other type of trigger is, maybe data changing, and who you want to tell when it runs and how, like in what channel, if there's a problem maybe, or if it completes. And then you start to add your checks. Well, what should happen at 2 o'clock every Monday, right? I want to run data checks to make sure that nothing looks bad and broken. I want to score my table, and I want to bring in last month's data and score it by my model to do a little bit of a back testing flow. So there's lots of different things you could put into an automation scenario. You may be coding these today. And then you say, well, let me wrapper this entire thing into a bundle that I can just bring into an isolated server so that people changing the design doesn't break this thing. So I want to put it into an isolated environment. And this bundle, I'll just click on one here, contains everything that you would need to recreate this project in another environment, including any kind of save models with the coefficients or the weights or whatever you might need. And then what we would do is we would publish this on a deployer. And I'll talk about the deployer in a minute. We back out here and say, maybe the goal isn't batch scoring. Maybe the goal is to create that API that you can embed into some existing application for the Salesforce. So in that case, you would kind of take a slightly different approach. You create an API, either a new service or an existing one, name your endpoint, and then you kind of design your endpoint. Do I need to enrich it with lookup tables? Do I want the API to also return like individual explanations of why that person was scored as likely or unlikely to purchase or to prescribe, and so forth? And then again, you push it to the deployer. Now, the deployer, which is just another menu here. Again, batch side, API side. You have these bundles that I've put in here, and this is my projects. Now, something that is quite common, you probably all know, is having multiple environments for sandbox, dev work. Maybe you have kind of dummy data stores and things like that. And then you have typically a test or QA environment and a production one. And in many cases, we'll talk about this when we get to lifecycle, but in many cases, this is kind of a shadow environment for shadow scoring. So here I can take a bundle, I can deploy it, and once it's deployed, now I've got all the different settings. What is this connected to in terms of my infrastructure? What kind of code environments do I have? And this might have specific Python or R packages. And do I want to turn on those automatic scheduled scenarios? Now, if we go down the API side, it looks the same. You've got API endpoints. We've pushed here, you deploy it, put it either in dev, test, prod, and now you've got a running model. So I'll just pick on one here that I think is active. You can see we had a few calls to it. This is just for dummy purposes. Okay, so let me check the chat. Okay, we'll come back to that question. So now let's go back to project is in deployment. Okay, we've got our first instance of it being in orbit. Now what? Well, now we have to see whether or not it's degrading, because the environment changes, right? Maybe the target distribution or the definition of what fraud is or what prescribe means changed, or maybe it's that the data, the composition changed. And COVID was a great example of the environment changing and all your models no longer just being relevant anymore. So first of all, before you deploy, you want to understand what your baselines are. So that might mean going to like a table. And in this case, this would be the table that I, let's say, train my model on, or a prepared table. And you can set up things like, what should this look like? I should have 14 columns. This one should never be empty. The max and min ranges should be this. If it doesn't look like that, then something's wrong with my data pipeline. Or you can go in and you can actually say this table is a baseline. And my model was trained on it. So if new data doesn't look like this on a bunch of different dimensions, if it drifts more than 10% away in profile, then it no longer looks like the data I trained my model on. So there's lots of different ways to create a baseline. And then these types of metrics are what you would check in a dashboard, for example. So whether you do this in Dataiku or in the tools you have, from a daily dashboard view, you might want something like this that just throws up an alert or sends an email if something fails a certain check. And you also want to monitor your model for drift, right? So this is about kind of the data pipeline. If I go back here to my model, You can see here, I mentioned an evaluation step. Well, I take last month's data, push it back through and say, how did we do? Were our predictions good? And this step does that check for you, and you can kind of get the scored results, and you can also historize those metrics. So in this case, you can see on different, looks like months, this was monthly scored. You can see what was my precision, my recall, my AUC, ROC, build charts on it, right? This might be the way that I, as a person monitoring a dashboard, might look at this and say, oh, something bad is happening in May. My precision, my recall, my AUC, they're all going down. So this is great for detecting model drift. The next step is kind of, well, let's determine whether or not this drift is significant. And so on any given model, let me see if I have one already loaded up. This is like if I clicked into the model object and I have versions, I'll show you. I can do a drift analysis. And again, you can code your own. There's lots of different strategies for determining whether or not there's been drift. In this case, we would consider drift as the p-value being statistically significant. Can a random classifier determine the difference between this new data coming in and the data you trained your model on? If you can, and it doesn't, the pattern doesn't overlap this nicely, then there's a chance that your data looks different, the world is different. But then the next question is, well, what if it's different, but it doesn't matter? What if the things that make it different aren't important anyway to the model? So data can change and still not have a material impact on model output. So you want to look at things like feature drift. Which features drifted? Maybe there's new categories that came into the picture or something. And was it important to begin with? So one strategy for calculating model drift is to look at the ground truth and understand whether or not you did a good job and whether the model is still predicting that. But in many cases, I'd say most cases, it takes too long for the ground truth to happen, right? If you're like in durable goods like cars or appliances, you might wait years before you determine whether somebody did in fact repurchase from you, or whether or not, if you're a bank, the person is actually going to default on their loan. You could wait years, and you don't want to wait years to retrain your model. So then you start looking at things like checking the data. Is the data changing? And that's usually a better strategy to have more frequent retrains, is to look at whether the composition of the data is changing in the absence of knowing whether you were right or not based on the ground truth feedback. So hopefully that makes sense. I know it's kind of a fuzzy topic, data drift versus concept drift, and all the different ways to monitor it, but we can talk more about that at the end. Okay. So let me look at time here. So next is model management. So let's say you've put your model into production, you're looking at your drift scores, it looks like something's starting to change. What do? Well, of course, you can come back and you can go into your model and you can manually retrain it, right? And we definitely didn't even talk about how to train a model, but there's ways that you can definitely retrain. That's very manual. You really don't want to do that if you've got hundreds of projects in production. You want, for some extent, for this to happen autonomously, and then only if something goes wrong or the data starts to change in a way that you don't expect, do you want humans to have to go in and inspect it. So again, if we go back to these scenarios, this is really where you want that to happen. You want it to check certain things and then just push a retrain. Take the new data, retrain the model using the same inputs, the same handling, the same settings in terms of your optimization metrics and so forth, and then just produce a new one and then push it into maybe a dev environment to see whether or not you get good results. And so all of these steps that I'm showing you here in our user interface can be done programmatically. And in fact, for our larger clients who do tons and tons of operationalization, they code everything just via the API. But this transparency really makes it clear to anybody who's just coming on the project for the first time, kind of what the logic is for all these automation steps. So the API enables you to really do these kinds of checks and retrains and repushes and integrate it, let's say, into your Jenkins pipeline or maybe another CI/CD framework that you have. And this, this kind of thing where you have dev, test, and prod really becomes important with that, like where you put it automatically. I should mention here, I was actually just on the page. I wonder if I can go back. Let's see. That when you do have, let's say, a new API, you're not always sure whether or not a new model is going to do better. And in some cases, you can't serve the customer with both. So in the case of the classical A/B testing, let's say you have a marketing offer and you want to say, I'm going to give you 25% discount and 30% discount and see which one works better. Well, you can't send the same person both those discounts because, of course, they're going to pick the 30 every time. So you need to do population sampling to make sure that you're sending groups with similar profiles, these two offers, and then you're doing a proper statistical experiment. So definitely, we have tools, of course, to help you with A/B test population creation. But when you're in your API, make sure that you have something set up to dispatch to different versions. So for example, if I say, well, I want to try V16 and V17, maybe 30% go to the new one and 70 to the old one. Then on the back end, I can come and monitor things like, how did the different versions do in my predictions? This one looks like there's something really wrong, right? In this case, we're predicting airline flight delays, but V7 predicted no delays across any airline. So as somebody monitoring this project, I see that and I think, oh, we need to roll back to V6 because this is wrong. So if you have any questions about this, let's put it in the chat. We'll cover it in just a few minutes. Also on this dashboard, I think we had some cost resource usage. So it's like, what's the the time that it takes to deliver the results of this API? And this would be something to monitor also. If the prediction starts to take a really long time, something might be wrong, or you decide that the individual explanations are taking too long, you'd rather have faster responses for your calls, then you can maybe take that away. So this kind of helps the ops person monitor that usage as well. The last thing I want to touch on, I know I'm hopping around a lot, this is like a big topic, is governance. It doesn't quite fit in to the others, but it's so important to have a strategy for ahead of deployment, because if one of these things on the right happens, it's almost too late at that point to figure out what you're going to do about it. So all these questions should almost be asked in the design phase so that you make sure that you're designing models that are fair and you're testing for bias and you're checking your data for bias way earlier than you're ever thinking about deploying. And what's the risk? If we have one of these reputational disasters where you end up in the news for biased predictions, like what is that? What is the cost of that? Is it acceptable if the service goes down? If we can't seamlessly convert from model versions? And how can we make it so that the knowledge of how the system works is not tribal knowledge locked into two people's brains? If those people leave or they change teams or whatever, is the process transparent enough that regulators or just new team members can actually follow it without too much effort? So even though governance asks all these kind of uncomfortable questions, a lot of times their interests really intersect with the interests of the ops people anyway. So for example, the governance folks say, okay, we have to have tight security. Only certain people should be able to deploy, or we need to have audit trails and documentation, or we need to have a failover plan. Well, those are things they need for compliance, but MLOps wants them anyway because they don't want people breaking their system, and they need those logs for troubleshooting and the documentation for troubleshooting and whatnot. So it seems like a lot of extra work, but in many cases, these really help the IT engineers anyway. And so lastly, before we kind of open it up and just do more interactive Q&A, the takeaways here, MLOps is not just about a push button, like an easy button. It's like, all the companies will say, we do MLOps, but it's really about having the processes and checks in place at every stage of the life cycle, not just the back half, but also even data access, data, that kind of data stewardship, understanding where the data is coming from. All of that has to be taken into account, and that's processes and then many roles. You can't have MLOps without data ops. We talked about that. If you're just getting started, monitoring for pipeline health and service health and data drift is enough. All the rest is important, but the first starting places are making sure that that those mechanics, the plumbing isn't broken, and that you're still checking that your model's relevant. And then lastly, don't forget about the governance piece, because that can cause a lot of problems for setbacks if something bad does happen. Then there's not a lot of organizational trust that continues to let you keep funding these types of AI initiatives. So with that, I'm going to open it up for questions and answers. I am definitely not the expert at MLOps at my company for sure. So we have so many people over in the R&D and product management groups who really love this topic. And I would encourage you, if you're interested in this, to check out the O'Reilly book. It's this PDF versions. It's an easy read. Covers all these topics in really great research depth. So please go ahead and check that out. And with that, I'm going to open it up for any questions. And I will look at the chat now. Let's see. Okay, so the first question is, can you open the bundle in an environment outside of Dataiku? So the bundles specifically are meant to be used in Dataiku servers. That said, you can, of course, take code or model objects out of Dataiku and use them in existing systems. So we can export models as, PMML or jar files, notebooks, even in some cases. So the assets can go out, but the bundle is really meant to work in Dataiku. So hopefully, Amy, that answers your question. Monica asked, does this work for big data? Absolutely. This is the whole goal of a lot of, Dataiku and other companies similar to us, is helping you do this at gigantic scale. So everything I just showed you is really meant to scale anywhere from, tens of records to millions of records. And one of our big principles is leaving the data where it is and processing it in place so that you're not copying and moving big amounts of data across the network. There's no limit to data set size. You can set samples in your design view, what you're working at. So you might only want, 100,000 or 10,000, just so you have responsive feedback as you design and manipulate. But when you hit run, it works on everything. And usually it's optimized for that data source that it lives in. SQL, Spark, all the Hadoop technologies, that kind of thing. Okay, next question is, does my company need to have a different node other than the dev and automation nodes for MLOps? And I'm not sure, Amy, is your question specific to Dataiku? you can just type that in there. Yes, okay. So you can do, depending on your license, you can do some scenarios, the scheduling I talked about, just on the design node. And for smaller companies, that might be okay. In general, for larger enterprises, they use the automation nodes for that logical separation of sandbox and, real life connections. So there's not a technical limitation, but our licensing really is oriented around, if you're going to be putting jobs into production, you want to use an automation or an API node to do those. And that's where that bundle comes into play. Okay, while it is nice to have involved governance processes right from the start, what would be your recommendation for doing governance when multiple models are already preparing for production deployment? So I would say create maybe an internal workflow or a checklist that both the business, data science, and IT can get behind when it comes to what are the questions we need to have answered before we all feel comfortable that this is a safe model and it's well documented. And even for models that are already under development, you can still go back and have the designers go and answer those questions and then figure out a way to cleanly document them. And so then when you have new versions, they're archived. If you're not using Dataiku, I'm not sure if you would do that just in some third-party system. Maybe you're using Git and there's a certain kind of documentation you want to have in your repos. For us, a lot of that documentation is done automatically. So it's a non-starter, but I would say it's definitely not too late to have them write down what features they used and why, what algorithms they used and why, and that's going to help the people who operationalize it reverse engineer that logic. I know we've got a fairly technical audience on the line. Go ahead and enter any more questions you have. Okay, are there plans for Dataiku to be integrated with data governance tools so that checks for data governance can be implemented as part of scenarios? We do have plans for later this year and next year to increase our governance kind of tool set. But the first place we're going is a native homegrown kind of watchtower with workflow management and model registry and things like that. I can definitely check whether or not external governance tool integration is on the roadmap for next year, but at least for this year, it is not. That being said, if the check can be done programmatically, then it can already be integrated as long as those other platforms allow for code. So for example, if the check is, does the data have this type of schema or shape or some other aspect of it, then you can definitely check that all with just an API call. And as long as Axon or whatnot can accept that, then you could just do that manually today. But I'll take a note of that. Any other questions? Okay, I'll take that as a no. So with that, I'm not sure how you want to close things up.
I'm here, I'm back. Thank you so much, Christina, for the wonderful workshop. And thank you everybody for attending. We really appreciate it.
Yeah, thanks for the opportunity.
Thanks everyone, we'll see you at the conference.
Yep, visit our booth if you have any more questions.
Yeah, for sure.
Take care.
Care.